We're making a start on a 2017 mat, so as usual that means the multiple choice questions, all 10 of them. So we start off with let f of x be that function for what values of the real number k does the graph y equals f of x have two distinct real stationary points. So we've got f dash of x, then let's differentiate 6x squared minus 2kx plus 2. So we want this to be equal to 0 and have more than one solution. So we want 3x squared minus kx plus 1 to be equal to 0. We need two solutions. So we need our b squared, which is k squared minus 4ac minus 12 to be greater than 0. So that means we need that k has got to be greater than root 12. Or k has got to be less than minus root 12. And that is 2 root 3, isn't it, for each one? So where are we going on here? So it's got to be less than minus 2 root 3 and greater than 2 root 3. So it's B. Right, so it's A, fairly standard question. B, the minimum value achieved by the function that equals what? So fairly horrible looking thing. I think the substitution is going to help on this. So let's say let y equal what, cos squared x, and then we can say that f of y is going to be 9y squared minus 12y plus 7. F dash of y, 18y minus 12. And we want a minimum on this, so we're going to want to set that equal to 0 and then check that our f double dash, that comes out at 18, so that means we've got a minimum. So that's good. So we've got that y is 12 over 18, so 2/3, and that is our cos squared x. So we want the minimum. Well, actually, it doesn't even matter about putting that in. We can just come straight back into here because we're not looking for when the minimums occur. That's sort of standard. I just went into default mode of let's try and figure out what angles we've got, but we don't care about that. So we're saying then that we've got 9 times 4 over 9 minus 12 times 2 over 3 plus 7. So we cancel those, we make that a 4. So we've got 4 minus 8 plus 7 is 3. A. Right, on to C. The sequence AN has the property that AN plus 1 is AN divided by AN minus 1. Every n greater than or equal to 2. So given us the first two numbers, 2 and 6, what is A 2017? Right, so there's probably going to be a pattern here. Let's go through these then. So 2, 6. So what are we doing? We're taking the previous one and dividing it by the one before that. So 6 over 2 is 3. 3 over 6 is a half. A half over a third is a sixth. A sixth over a half is a third. A third over a sixth is 2. 2 over a third is 6. Right, so we've got our block then. So how many is that? 1, 2, 3, 4, 5, 6 in each block. So we need to divide this by 6. So 2017. Divide that by 6. So that's going to give us 3. And then 3. And that's left remainder 3, and then 6, and then remainder 1. So that's what we got left over. So we're going to be on the first one of the batch. So it's going to be 2, which is D. Okay, they haven't done much so far. Diagram below shows the graph of y equals f of x. Okay. The graph of the function y equals minus f of minus x is drawn in which of the following diagrams? Okay, well that's not up to their usual graph spotting standard because that's going to be reflecting x-axis, reflecting y-axis, and it doesn't matter which way around we do them. So C. Oh, that was a bit of a gimme. Yeah, is that really all they want? Minus f of minus x. Yeah, okay. Right, well that's that one. E, let a and b be positive integers such that a plus b is 20. What's the maximum value of a squared b? So, well, we want to get this just with one term in it, don't we? So let's say then that b is 20 minus a. And then we can say, well, f of a is a squared times 20 minus a. So we want to then differentiate this. which is going to give 40a minus 2a squared. No, 3, sorry, a squared. So yeah, that's giving us that. We want that to be equal to 0, and we also want our f double dash to give us a maximum. So that's going to be 40 minus 6a. So this is 0 when, what have we got? A is a positive integer. So a, well, we can get rid of the zeros and say that a is going to be 40 over 3. That was 40 over 3. Is this going to be negative? Then yes, it is, because we've got 40 minus 80. So that gives us a maximum at a equals 40 over 3. But a is a positive integer, so the best we can manage then is 13 on this. We can't do any more than that, can we? So a max is 13. Maximum value of a squared b then is going to be 13 squared, and then b is 20 minus 13, so 13 squared times 7, 169 times 7. So 700 plus 490 minus 7, which is 1190 minus 7, so 1183, which is D. At least it came out as one of those numbers, which is always good. F, the picture below shows the unit circle, where each point has coordinates cos x, sin x for some x. Which of the marked arcs corresponds to tan x is less than cos x is less than sin x? Interesting. So, well, let's look at some of these. Well, it's definitely not A, because we've got cos x there is greater than sin x, so it can't be A. And, well, same for E, because sin x is negative. And, well, B fits with sin, B and C both fit with sin x being greater than cos x, so that's good. So let's think about tans. Well, it does with D as well. So tans, well, for D, if they're both negative, tan will be positive, so we can't have that one. So we need to, what do we need to do? We've got B. So if that's going to make, we need to have one of them negative, otherwise tan's going to be too big for B, isn't it? If you've got tan there, sine is bigger than cos, but then you're taking whatever sine is, dividing it by something less than 1, so tan will be bigger, so it can't be B, it's going to have to be C. It's the only thing we got left, where you'll get a negative tan. Okay, all right, so C, oh yeah, C is C. Right, they've got the letters down there. Fell off the bottom of the screen. G, all right, for all theta in the range 0, including 0, up to 2 pi, but not including 2 pi, the line that divides the disk x squared plus y squared is less than or equal to 4 into 2 regions. Let A of theta denote the area of the larger region. A theta achieves the maximum at how many different values of theta? Okay, so what have we got going on then? So this is just a straight line though, isn't it? So it's just a straight line. Let's get this into something a bit more sensible. So y is equal to 1 plus x plus 1 times tan theta. So y equals tan theta x plus 1 plus tan theta. Right, so that's what we've got as our setup. So we're varying around. As theta changes, we're changing the gradient and the intercept. So we've got some disk. We've got some disk of radius 2. So when theta is 0, we've got that y is 0, x plus 1. So y is 1. So we just have this horizontal line. Okay, that's meant to be horizontal. Then as theta increases, the gradient increases. Well, until eventually it then becomes negative, doesn't it? So the gradient's going to go round, is following tan. So it's following this setup that we have for tan as we're going from 0 to 2 pi. So it's going to get steeper and steeper and steeper. It's going to be epically steep and negative. Yeah, so the gradient, this is turning around in a circle, isn't it? Gradient's going down and the intercept is going up and up and up, and then that's going to flip as well. So it's going to keep on going upwards until it's vertical. And then what point is it rotating around? That's the thing, isn't it? I mean, can we get a handle on, so because the gradient's definitely going to be going all the way around. So we're doing one complete loop of this line here, rotating it about. If the center of rotation is inside the disk, then we're going to get two answers, because tan repeats itself. We've got two solutions in here because we're not including the end, so you can't have the 0 one being the 3 solution option. So, but where's it rotating around? What if we had other simple numbers? Well, a simple number to put in here would be if theta was pi over 4, because if theta was pi over 4, then we're getting y is equal to x plus 2. So that is that, yeah, it goes through there as well, doesn't it? So it goes through that line, and then so that if there is a rotation point, it will be wherever that is. What would we get another one? What would be another easy one if we had 3 pi over 4? If theta was 3 pi over 4, then we're getting y is minus x. So that would be going through here doing that. I wonder if they all go through the same point. So you'd have to have that y is 1. So it will be going through minus 1, 1 would be in that case. If it was here, it's going through minus 1, 1. And we know that goes through minus 1, 1. So it's kind of pointing to, it's not conclusive, but it's pointing towards that this line is rotating around this point minus 1, 1. In which case, you're always going to be dividing the disk into 2 regions, and we're going to get every possibility twice, because that's the way that tan works. It goes through every possibility twice as we go from 0 to 2 pi. So it's going to have to be B. I can't see any other way of getting around that. That was a significant step up on the previous questions. H, in this question, A and B are real numbers. A is non-zero. When the polynomial x squared minus 2ax plus x to the 4 is divided by x plus b, the remainder is 1. When the polynomial, that's a different polynomial, that's got that as a factor. Right, so we're doing remainder theorem, factor theorem. So we put minus b into the first one, so that gives us b squared plus 2ab plus x to the 4 has got remainder 1. And then the second one, we're putting x is 1 over a in. So we'd have b over a squared plus 1 over a plus 1 is equal to 0. Okay, right, so that's what it is. So let's just multiply through then by a squared, I think, on this one. So we'll say b plus a squared plus a is equal to 0. Then we can sub in for b in the top one. So we'd have minus a squared plus a all squared. So that is just a squared plus a all squared. The minus doesn't matter. Then we'd have minus 2a of a squared plus a. That's taking the minus into account and changing that one. And then plus a to the 4 equals 1. So a to the 4 plus 2a cubed plus a squared minus 2a cubed minus 2a squared plus a to the 4 equals 1. They cancel. So that's 2a to the 4 plus, no, minus a squared equals 1. Okay, and we want a to be non-zero, so that helps, doesn't it? We can divide through by one of our factors on that. So anyway, we've got a squared, 2a squared minus 1 is equal to 1. So we need 2a squared, we need a squared to be equal to 1. So a squared equals 1, a equals plus or minus 1. And how does that help with b? So if a is plus 1, then b is going to be minus 2. B equals minus 2. And if b is minus 1, then we're going to get 1. Right, let's just write this out again. So b is minus a squared minus a. Just to make sure I'm getting this right with a minus 1. So that'd be minus 1 minus minus 1 is 0. So minus 2 or 0. Cool, with b. Well, actually, by the time we got minus 2, we were set up on b being the answer. Okay, there wasn't too much to do there. Let a, b, c be greater than 0, a, b not equal to 1. Right, the equation that has a repeated root under which circumstances? Log to base b of b to the x, well, that's just x squared. Then we've got this ugly looking thing. So that next bit, I think we're going to want to split these out, aren't we? Well, that is x log base a of c minus log base a of b. Then we've got a minus, let's go for minus log base a of b log base a of c, and that's got to be equal to 0. Okay, so what's that telling me? Yeah, what is that telling me? Well, we've got 4 terms. Maybe it factorizes. You never know. Yeah, because we have got, actually it looks like it does, doesn't it? If we add, so we've got our x squared, and then we've got x multiplied by each term, and the terms multiply together. Yeah, so we've got x minus log base a of b, x plus log base a of c. It's got to be equal to 0. And what are we even trying to do? We're trying to get, so we want a repeated root. So these things will have to be the same as each other. So we get a repeated root when minus log base a of b equals log base a of c. So that would mean, well, that is the same. We get rid of the minus. That's 1 over b. So we need that c is 1 over b, which is d. Excellent. Right, that wasn't too bad. And then the last one, J. Which of these integrals has the largest value? You're not expected to calculate the exact value of any of these. So what have we got here then? We've got some x squared minus 4 times sine to the power 8 of pi x between 0 and 2. Okay. C looks like the simplest one to think about. At least we can get a grip on something. So sine to the power of 100 between 0 and pi. So we've started off with that, and that's, but yeah, so that's going up to a maximum of 1. So when we do that to the power of 100, we're going to get something pretty extreme. Like, you know, we're going to get close to 0 on this, but it's a little bit more than 0. So a little over 0, which doesn't suggest it's going to be the largest unless all the others are negative. So that could be an interesting thing to look for on these, whether we're getting anything negative or not. This one's got a big range on it, this last one. So going up to 8 pi, you've got sine cubed minus 1. I think we're just going to have to try and pick these off one at a time, really. So sine cubed minus 1, well, shifting it all down minus 1 means that is going to be all below or on the axis, isn't it? Because, okay, we start off with our sine, okay, we're going up to 8 pi, but whatever, even if you just do one loop, we can do this 4 times. It repeats, so we're going to get the same old thing. But we cube it, which is going to make it more extreme, and then we drop it down by 1. So that's all going to be below the axis. So that's negative or equal to 0. So we're going to end up with that being negative overall. Right, have we got any others that are going to be negative? Certainly not B, and certainly not D. They're both positive. So at least we've ruled out E so far. What about A? Is A going to be negative? Yeah, because we're going between 0 and 2. So this first bit is always negative, and then that bit's positive. So A is negative as well. All right, so at least we've made some progress. That's A and E gone. The we need to try and quantify these other ones then. So what's happening, let's have a closer look at B. So with B, we start with our cos x. We're going between 0 and 2 pi. So we've got that. We're adding 2 to it. So that means we're then going to something that's looking, well, it's the same shape, but we're now going from 1 to 3. And then we are cubing that. So that's going to go up to 27. Wow, okay. So we've got some kind of 27, we've got some kind of 2 pi. We don't have to work this out. So we know that B is greater than 2 pi, as in greater than that rectangle, and it's less than 54 pi. Right, let's put a range on B, and it's wiped out C, because C we're saying is more or less 0. And then for D then, so let's do steps on this. So we're going between 0 and pi. So we've got that first of all. Then we're doing 3 minus this. 3 minus that. Right, so that's all going to be in the positive area. So we're starting at 3. We're going down to 2. We're going back to 3 again. So we're going to have something that's looking like that. Then we're doing that to the power. So that's 3. And what was this? That's 2. Then we're doing that to the power of 6. Okay, it's going to make it more extreme, but we're doing that. We're doing up to pi. So that means that D is going to be less than 3 to the 6 times pi and greater than 2 to the 6 times pi. So 2 to the 6 is what, 64. So D is greater than 64 pi and less than whatever this is going to be, which is what, 981s. So a lot. 9 times 81. Which is easy enough to work out, but we don't need it because D is greater than 64 pi, B is less than 54 pi. So it will have to be D. Yeah, that was an interesting question, that last one. I would say that was a fairly easy set of 10. You know, J was an easier one. I was fairly straightforward. The H was straightforward. G, I think, was the toughest one on there. That was easy for F. E was pretty easy. D was weirdly easy. C was fine. B was fine. A was fine. So yeah, I think that's a generous bunch. By far and away, I'd say the most difficult one was G, and then the others were pretty generous all round. So we'll see how the rest of the paper pans out.